Welcome back, fine Python family, to the Python Made Easy series. This class is called Working with Classes. And in this class, we'll cover what classes are, how to use them. We'll learn about what makes them special. We'll look at inheritance and multiple inheritance, and inheritance attribute search. We'll extend a class. We'll look at subclasses and superclasses, the self argument, namespace as it relates to attributes, methods, constructors and operator overloading. We'll look at the init method, the if name equals main statement. We'll call a class as an import into another module. And as always, we'll be chock full of examples. Let's dig right in. A Python class is a coding structure used to implement new kinds of objects in Python that support inheritance. Inheritance is when a new object is patterned after an existing object. We say that this new object inherits from the existing object. An example, we may have an object called car, and then from this object we create various models of other cars that inherit from the object car. The new inherited car object will share some core properties, perhaps 4 wheels, it has a color, it can drive, it has doors, etc. Classes are instance factories. Instances represent the concrete items in a program derived from classes that may now be interacted with directly. What makes classes so special? The following make classes quite useful when building new objects. Multiple instances. Classes are factories for generating child objects. Every time we call a class, we generate a new object with a distinct namespace. Each object generated from a class has access to the class's attributes. Customization through inheritance. We can extend a class by redefining its attributes outside the class itself in new components coded as subclasses. Classes pose 2 special things. A special first argument called self in functions to receive the subject of the call, and inheritance attribute search to support programming by customization. We've already covered namespaces in previous classes in this series, but it bears repeating here for classes. A namespace is a mapping from names to objects. Examples of different namespaces: the Python built-in names that contain functions like dir, len, id type, zip, etc. The local names in a function, or even the global names in a Python module. There is no relationship between names in different namespaces. Now, when we apply this to attributes, an attribute is something an object has. In the expression foo.bar, foo would be the module name, and the module is an object, and bar would be an attribute of that object. In the example there, it's a straightforward mapping between the module's attributes and the global names defined in the module. They share the same namespace. This is a key expression for Python's object-oriented programming, object.attribute, with an example being import sys.path. So import sys, the sys module, would be the object, and the sys.path would be the attribute, right? Path would be the attribute. When we use this in relation to an object that is derived from a class statement, this expression sets off a search in Python that works like this. Find the first occurrence of the attribute by looking in the object, then in all classes above it from bottom to top and left to right. Attribute fetches are tree searches. And in Python, we really do build up trees of linked objects with code. A given class can inherit from a class higher in the tree than it. The higher class is termed a superclass. Classes lower in the tree are termed subclasses. These subclasses, being lower in the tree, and because searches happen bottom up, may override behavior in classes above them. Multiple inheritance is when a given class is linked to more than one superclass above it. Methods are functions attached to classes as attributes. Whenever we call a function attached to a class, an instance of the class is implied. So here we have a snippet of code. We have a class we've defined as class 1. Notice, class names by convention are written in uppercase. This class has 2 superclasses from which it inherits, class A and class B. Next, we have defined a method called myMethod. Self is the first argument received automatically. It provides a link or a handle back to the instance to be processed. Any values we pass to the method go to arguments after self. For example, we include here the argument blah. It must appear after the required self argument. Self automatically refers to the instance being processed, the subject of the class call. Let's look at what constructors and operator overloading is. Init is automatically called each time an instance is generated from a class. The new instance is passed to the self parameter of the init method. The init method is the constructor. It is responsible for initiating instances when they are made. If there's no init present, class calls return an empty instance without initialization. The init method is from a class of methods known as operator overloading methods. Note the double underscores at the beginning and end of its name. Operator overloading objects coded with classes intercept and respond to operations that work on built-in types, such as addition, subtraction, slicing, printing, etc. They enable objects to be more tightly integrated with Python object models. So let's dive deeper into this init or constructor method. So we have a class here called person. The class statement creates a class object and assigns it a name. Just like def for functions or methods, it is an executable statement. Here we have our constructor method. Init is the constructor for its class, responsible for creating instances of our class with the passing in of the value for object or parameter name in this case. Here we have self, which represents or corresponds to each instance that gets created. Now we have a second method, the string method. This is run when the instance object gets printed. It's used to ensure that our printed output is readable to humans. P1 is our call to the class that will create our instance object Joe of class person. This instance will now have all the attributes of its parent's class. In this case, it's only the name attribute. Attributes are of two types: data, what the object is or what it has, and then procedural, what it does. Now on the bottom here, I can make the variable self.n or whatever I like as long as I allow it to equal the second argument name from the method's header, and I change it in my code when I use it. And here you notice I created a second instance of the class here. I'm not limited by how many I can create. And here we're going to have a slightly more useful class example for you, a little bit more meat on these bones here. So I have a script. It starts here with part 1, and then it continues on the upper right hand side, part 2. So I created a class and I call it instruments. This is our constructor method with our init. It takes 3 arguments: category, name, and sound type. And then here I give each of the arguments a variable name starting with the keyword self. I want you to notice here all of these methods are what are known as getters and setters, or mutator methods. They're used to control changes to a variable. Some say that this is not a very Pythonic way to code, and later we're actually going to see different ways to do this using something called a property decorator. More to come on that. Down at the bottom is our string method, and of course that deals with a pleasing output format for instances. Note here the last line of our code above. When I print out v1, this returns the output of our string method, so that's what it would look like right here. Here I create 3 new instances using attributes that align to the init method. And here I use setters to change the attribute values for G2, our instance G2. And note, I have several print methods with and without using the getters methods. So it's very flexible what you can do with Python classes. And by the way, I'd like to point out that all of the code in part 2 is flush with the class statement. So it's in the global namespace, it's not indented. Just because you can't see it here, I wanted to make sure you were clear on that. So here we continue on what we built in the very last slide. We saw our class instruments. Now we build a child or subclass to class instruments, and we call it guitars. Okay, so here is our subclass guitars. And you see it inherits here from the parent class instruments. We set up get_nums as a class variable to count how many total guitars get created through this class. And of course, here we have our instance constructor method with our double_init, and it takes in self, category, name, brand, sound type, year, and G type. Now notice, 3 of those come from our parent, category name and sound type. So you see, as in the second line here in our instance constructor, we have instruments dot and then an init that ties us back to the parent class instruments. So we have those same 3 attributes there that we actually are then passing again into our instance constructor. And we have our same attributes. We have our same variable set, self.brand, self.year, self.gtype, self.gid, and self.gid equals guitars.get_nums. This is tied to the class variable right up here. Then we have guitars.get_nums plus equals 1. That means every time a new instance gets created, it will increment 1 more time. Then here we have another method called set_play. This sets the value for attribute g_type. And then we have get_gid. And this get_gid will show me the GID for any particular instance. And of course, we have our string method here that will print out this guitar is a, and then the name plus the brand. And now, of course, we can validate that this is all working by looking at our print statements. So first we create a guitar G3, and we pass it in all the requisite attributes. String for category, T5 for name, Taylor for brand, Sweet for sound type, 2012 for year, and acoustic electric for guitar type. And then we print that out. When we print it like that, print G3, that's going to pick up on our string method. So it should say this guitar is T5, Taylor. Then the next thing we do is we create another guitar G4, and that's a Gibson Jumbo, and we print that out this time by saying something very specific. This Gibson Jumbo is, and then we call it the variable G4.soundType. So we just want to pick up on the sound type, and it was built in, and we pick up on the year. So when we do that, the next print statement says this Gibson Jumbo is booming, and it was built in 1966. Then we ask how many guitars have been created. So now we want to go right to the guitars.getNums. We want to go right up to that variable, that class variable that was created to determine how many guitars have been created since we started using this function. And it tells us 3. And then what is G4's GID? It tells us 2. And print G4 gtype, acoustic. And then we set G4 set play to classical. And when we print that out, it indeed returns classical. So everything's working exactly as we would expect. Now let's expose you to the if name equals main statement. There are 2 ways to run code in a Python script. We can run the file locally, or we can import the file as a module to another file. But oftentimes we want to test code at the bottom of our script to verify it's working correctly. However, we don't want that test code to run if someone imports our script and uses it. We only want that to run if we are executing the script locally. How do we make it so we can use this same script for import and testing purposes and only see the output of our test code when we're running the script locally and not as an import? Enter the module name check. When the Python interpreter reads a Python source file, it defines the name variable. And again, this is a dunder, magic method. If you're running your source file as the main program, it will hard code the string main to the name variable. So if we simply have our test code in an indented block following the statement, if name equals main, just like I do right here, the code in the block will only be run when we execute locally. It will not run when our file is imported. So let's see this in action. Okay, let's see how if name equals main works in practice. So we have our main script right here. We have our class guitars, and then we have some test statements here at the bottom to verify that all of this functionality is working. We also have a caller, and from this we import the functionality from our main script. So we do from PyClass, the name of this module, import star. So we import everything. And in the caller, you see we create another instance of our class guitars, and we give it the requisite attributes, and then we print it out. So what should happen, because we have the if name equals main, is when we call this directly, this should print out everything here in this indented body of the if name equals main, all our test information, right? All our test statements. But when we call it here, it should not do that, right? When we call it here, all it should do is trigger off this string function or the string module, and it should say this guitar is, and then based on what we passed in this case the name, which is Les Paul, and the brand, which is Gibson, it should say this guitar is : Les Paul Gibson. So let's try it with running it directly first. And yes, we see we get, and I'll make this a little bit smaller so we can keep it, we see we get all of this information down here in these statements that prints out. Now we'll run our caller. Right, this guitar is a Les Paul Gibson. So it ignores all this, it doesn't print it out, and it only prints out what we would expect. So that's how if name equals main works. If you have questions, let me know. So more on methods. Methods are just function objects created by def statements nested in a class statement body. Methods provide behavior for instance objects to inherit. Methods work in exactly the same way functions do, except that a method's first argument always receives the instance object's self. Therefore, Python always automatically maps instance method calls to a class's method function. So if we call a method through our instance like this, myInstance.method with 2 arguments, behind the scenes, Python receives it as the following: class.method, myInstance, and then the 2 arguments. So Python determines the class by locating the method name. The self argument is very significant as it's the method's link back to the instance that is the subject of that particular call. And we'll drive home these concepts that we just covered by looking at some code. So working with methods. The printMe function becomes a class attribute because it's within the new class 1's scope. Therefore, it's available for all new instances. What happens when we call the method printMe in this way? First, printMe, the method, is located by inheritance. Then the self argument gets automatically assigned to the instant object, in this case, inst1, down here. The myText parameter from the method printMe gets the argument hello because that's what we're passing. Since Python automatically handles the first argument self, we only need to worry about parameters or arguments after self. In this case, there's just one called myText. So of course this outputs the string hello as seen right here. Call to the method through a class is permissible. So we have here inst2 equals new class 1, so a new instance. Now we say new class 1, we qualify the printMe method with new class 1.printMe. Inst2 is our new instance here, and we pass it what's up instead of hello. This has the same effect as calling it through the instance. As long as we pass the instance in 2, we can't call the class directly. We must have an established instance to the class. You see how I created an instance of the class inst2 first. Otherwise, this would not work. Okay, Python family, thanks for watching till the end. I hope you found this useful. If this has helped you, consider helping me to continue to bring you and others this type of content. Helping is easy. First, subscribe to the Yogi Coder channel. Second, like this video and leave any comments you feel moved to. And third, share this on any and all social media channels. Thank you so much. See you in the next one.